Hello student, we already start our new chapter unit and measurements. Before we going to vacations for Diwali, so we already learned some points in units and measurements. First of all, we revise some points which we are already learned before we are going to next points. Okay, so first we learn the introduction point in unit and measurements, means what is the unit and system of unit and fundamental quantities and derived quantities and definitions of fundamental quantities and fundamental or derived quantities and unit. And we also learn this fundamental quantities, 7 fundamental quantities and its units, units and symbols. So all these points we already learned, and now we are going to a next points which are depending on these basic points. So our next point is dimensions and dimensional analysis. So what is the definition of dimensions? So the dimensions of a physical quantity are the powers to which the concerned fundamental units must be raised in order to obtain the unit of the given physical quantity. So what is the dimension? So dimension means is right in a form of LMT, means fundamental basic units. Means L means length, M means mass, and T means time. So this is the expression to write in the form of LMT. So this is written in always in square bracket. Okay. So now next definition is dimensional formula. When we represent any derived quantity with appropriate powers of symbols of the fundamental quantities, then such an expression is called fundamental formula. Okay, so we here see some examples how to find out dimensional formula. Okay, so here first example is we find out the dimensional formula of velocity. So velocity is a derived quantity which depends on 7 fundamental quantities. Okay, so we find out here dimension for velocity. So formula for velocity is displacement upon time. So this dimension written in square bracket always and in the form of 7 basic fundamental quantities we already learned. So here LMT form, okay, means length, mass and time form. So displacement is the fundamental quantity and time also fundamental quantity, means which does not depends on any derived quantity. So here displacement, for the measurement for displacement only written in length. So we find out length. So L1, and here M and T is not depends on this mass and time quantity. So here 0 written in the power is 0, 0. And similarly for time. So time here also a physical fundamental quantity. So T1 is here written and L0, M0 is not dependent on this time factor. Time. Okay, so here L1 M0 T0 upon L0 M0 T1. Now this quantity is a inverse quantity, written as an inverse quantity because it is a denominator quantity. So when we go to the numerator, then it gets a inverse, means -1. So here L1 M0 T0, so written in the form of as like L1 M0 T0. Okay, this is the first quantity for displacement. And this inverse quantity, means denominator quantity, written in the form of L0 M0 T minus 1. Okay, so comparing these equations, so L1 here and L0, we get here L1, M0 M0, so we get here power of M is 0, then here T0 and here T minus 1, so gets its T minus 1. So we get here dimension for velocity is L1 M0 T minus 1. So here we understand how to find out the dimensional analysis. So here, as the mentioned earlier, derived physical quantities can be expressed in terms of some combinations of 7 basic or fundamental quantities. So for convenience of the basic quantities are represented by symbols of as L for length, M for mass, and T for time, and simply for K for temperature, I for current, C for luminous intensity, and MOL for amount of mass. Okay, so second example for find out the dimensional analysis is we are considering here force. Okay, so again find out the dimension for force. So force is equal to, formula for force is mass into acceleration, ml, mass into acceleration. So we know that the dimension of the mass is m1 because L and T0 is not mentioned, is not necessary. So here 0 written is 0, and acceleration, dimension for acceleration is, so here acceleration means change in velocity upon time. So change in velocity, so we already found the dimension for velocity. So put up here L1 M0 T minus 1 upon time L0 M0 T1. So similarly, this quantity on denominator put up in numerator, and then comparing these powers, and then we get a dimension. So here written is force is equal to, here comparing these dimensions L0 L1, so we get here L1 M1 M0, we get here M1 T0 into T minus 1, we get here T minus 1 upon L0 M0 and T1. So this T1 get in inverse, so get here minus 1, so minus 1 get minus 1, we get here minus 2. So L1 M1 T minus 2 is the dimension for force, means here write in the form of M1 L M1 T minus 1 into L0 M0 T1. Here T1 means T minus 1 because of inverse. So we get here L0 L1 and L0 we get here L1, M1 and M0 we get here M1, and T minus 1 into T minus 1 we get T1 minus 1 minus 1 we get here minus 2. This is the dimension for force. So similarly, we all derived quantities find out the dimensional analysis. You understand this all points how to find out the dimension.